All right. Good morning, all you wonderful people. Let's go ahead and get started today. Let me move over to what we're doing today. There we go. So we are continuing on with the review. And with the review, we are going to go into solving equations. Now, I know you guys have been solving equations for a while, but we're going to work on stuff that are a little bit more difficult, a little bit more out of the ordinary. So, yeah, that's what we're going to do. So we are on the page of the packet. So it's the one after the one we just got done working on yesterday. Let's see. I don't know if I really have a page number, but it's going to be the homework packet that was sent back. And the one we are going to be working on is this one here. So you'll see that it has the same thing here. So there's that little thing in the corner there. But again, if you just see this sign in there, then you know you're on the right page. So when solving equations, now solving is a little bit different than anything else. Solving is the goal of solving is to get the variable by itself, variable. And this is different than evaluating. In evaluating, you're just basically trying to simplify an expression. Solving requires an equation, so you have to have an equal sign in there. So there is a little bit of a difference between solving and simplifying or evaluating. All right, so here are the basic steps to follow. If you look at my chart back here, that is my rules for solving equations. So usually the first thing you want to do is get rid of any grouping symbols. In this case, they say use distributive property if you can or if you have to. Now these rules they're not so solid. Sometimes you got to be a little bit flexible and find out which set works best with what, because you got to have to use your own, again, be flexible and use your own wits about you to solve these, because again, there's not really any particular set of steps that just say follow these steps every single time and you will always get the answer right. It doesn't really quite work that way with solving. Again, you have to be a little bit you have to kind of think on your feet with some of these. So, but these are just the basic steps. After you distribute, you will simplify each side by combining like terms. So take care of, if you have like terms on the same side, add, subtract, or whatever you need to do to those. And next, you need to choose a side for your variable. So you want to keep your variable positive if you can. And if you want, try to keep it on the left. Okay, so whenever we're, like, for instance, if I say, A, or let's just stick with a regular one. Let's go with X equals 15, all right? You usually say X is 15, or like if X was a person, like that person is 15 years old. Let me just make up a name, Arthur. So Arthur is 15 years old. You don't normally say 15 is Arthur because that sounds weird. So you usually state what you're talking about first, and then the other one. Now, sometimes you also have expressions where there are two variables or multiple variables. So again, you want to declare which one of the variables you are looking for first. And last step is to solve it, and that is to get the variable by itself. So there you go. That's all the steps that we have. We may not be able to go through all of these in the time that we have. So let's just see if we can get through most of these. I'm probably going to end up skipping some of these. Now, some of these are pretty easy, and I know that you guys are a sharp bunch, so I'm not too worried about some of these, but I'm going to focus more on some of them, the really tricky ones, the one that I know people get wrong quite often, or the ones I know people get stuck on or don't finish. So let's go ahead and do this one. So let's follow our directions. Let's get rid of this grouping symbol. Let's get rid of this parenthesis by using distributive property. So I'm going to distribute the 6 to both of these numbers. So 6n plus 30. Because again, I got to multiply both of those by 6 equals 2. Now I only have one variable, so I'm going to leave it on the left side on this side here. But I do need to get rid of some of these numbers. So you're trying to whittle it down. You're trying to get rid of all the other numbers besides the one you're looking for. In this case, we're looking for the n. So I want that 30 to go away from the n. So we're going to have to use our inverse operations. Now, yesterday I was a little bit careful about saying the word opposite because I know a lot of times other math teachers will say you do the opposite, but that's not really true because, again, multiplication and addition are not necessarily opposites. They are inverses. It's the same car driving forward or backward. So sometimes even I will call it opposite from time to time, just because, again, that's what most people are used to. So I'm going to minus 30 from both sides, and that should cancel it here. So 30 minus 30 is 0, and using identity property, 6n plus 0 is still 6n. So that didn't change anything. So we're going to leave it off. And let's go ahead and subtract 30 from this side. Now I have a large number that I'm subtracting, so that's going to make it negative. And it's going to be 28. So just like yesterday, if we can't divide it nicely, let's go for a mixed number. Now, why I'm going to do this? Why do we divide by 6n? Well, because we think of what's happening to the n. The n is multiplying by 6. Since it is multiplying, we do the inverse, which is divide. So we divide both sides by 6. And that 6 divided by 6 is 1. 1 times n is just n. And again, you use these number properties all the time, you just don't know it. Now, I'm going to end up having to divide it, which you can use a division bracket. I'm going to do that here. So 6 divided by 28, I'm going to ignore the negative for now. Now, 6 goes into 28 4 times, and it's going to be 24. And then I'm going to count my remainder. So it's going to be 4. And remember, top number is the remainder. Bottom number is the same bottom number, the number you are dividing with. So you have 4 and 4/16. I mean, sorry, 4/6. Oh, there was a problem like last class. I kept saying 16ths on, so I'm probably still focused on that. All right, so I know it's going to be negative. It's going to be 4 because that's not going to change. But I need to reduce my fractions. I'd like to reduce that fraction. So they're both even. So that means I should be able to divide them both by 2. So 4 divided by 2. And 6 divided by 2 is 3. And there we go. We have solved it. We have isolated n all the way by itself. So now we know the exact value of n. Now, remember, a solution is what you plug in to an equation to make it work. Like a car part. You know, if your vehicle won't start, changing the tires will not be a solution. So you got to find out exactly what the problem is and put that back in, and it will work, right? So, you know, if your car is not starting, it's probably your battery, alternator, starting motor, something like that. But again, you got to kind of narrow it down. Here I have another weird problem because this is something you don't see very often, and that is a division or a fraction. Now, I'm going to try to focus on the fraction ones in this case because, man, these fraction ones are pretty brutal. So first thing we want to do is I'm going to get rid of this fraction right here. Well, actually, you know what? Let's stick with the same pattern we've been using. I'm going to multiply this out, so I get 15 because I'm multiplying it by 3 minus 9x. Okay, now I can more clearly see what's going on. So again, look at the x. Especially with problems like this, I get students that either don't attempt these ones or, you know, skip them or get to a certain point and then stop. So you got to ask yourself, what is happening to the x? Well, it's having a negative 9 times by it. It is having a 15 added to it, and it is being divided by negative 4. So identify all of the operations that are happening to the x and decide which one is the best one. So I can't really minus 15 from both sides because it's still part of a fraction. I can't divide both sides by 9 because again, it's part of a fraction. I have to take care of those groups first. And if you remember from yesterday, fractions are grouping symbols. So that means I have to get rid of this before I can ungroup it. So we're going to focus on this -4 here. But remember, again, it's divide by -4. So we do the inverse of divide by -4, and that is multiply by -4. Okay, why multiply? Well, if we think about it, 4 times 15 is 60, and 60 divided by 4 is 15. So I basically just get 15 again. -4 times -9 is -36. -36 divided by -4 is still -9. So you basically end up canceling it out. But I think more teachers will usually do something like this, where it just cancels it out. And that's a much easier way to think about it. And in this case here, negative times negative should make it into a positive. So I get positive 60. Now from here, we got rid of that dreaded fraction. So it's going to be a much easier problem to work with. From here, we would just use our more commonly known basic steps. So minus 15 from both sides, -9x equals 45. And again, we got to do the inverse. So what's happening to the x? It is having a -9 multiplied by it. So I'm going to divide both sides by -9. And I need -9 because I want to cancel the negative, right? Because when it says solve, it means everything. That includes negative signs and 9. So there we go. Now x is entirely by itself. X equals, and we know it's going to be a negative because of our rules of real numbers. 45 divided by 9 would be 5, I think. And there we go. We got the first page. Okay, let's see how many more we have to go. I know it's quite a bit. I'm going to move on. Number 3, I don't think that's a particularly tough one. My first hour kind of went a little bit over time, so I might just leave number 3 out of there. That's not a particularly tough problem. You only have one variable and one group. But number 4, oh man, number 4. I must have spent like 10 minutes on just this problem alone. Now, I did make a mistake on this one in my last class, and I'm going to try to do this a much simpler way. I don't know if that really makes a whole lot of sense. I know fractions are one of those things that now that I'm looking at these problems, I'm thinking maybe we should have done like a fractions review before starting this. And I don't know how most schools do this, but I know with our school district, we don't really seem to put a big emphasis on fractions. But it could also just be that students themselves don't really value fractions as much as they do. So a lot of our fraction skills are lacking. Okay, so we're going to do a trick called cross cancel. If you're multiplying fractions, you look at the top number of one number and the bottom number of another one. So 15 and 5, these can both be divided by 5. So that's exactly what I'm going to do. Divide this by 5, and 15 divided by 5 is 3. Now, if you were to multiply this, you'd get something like 60 over 80 or something like that. And you would have to simplify it. By doing this, you are simplifying it before you multiply it. And that makes it a little bit easier because you have smaller numbers to work with. So I'm going to do the same thing with 16 and 4. 16 and 4 can both be divided by 4. So divide that by 4. Divide this by 4. 3 times 1. Oh, almost forgot the negative here. So that negative, be careful because it kind of looks like a fraction bar. and I almost missed it. 3/4. Because 4 times 1 is my bottom number, top number is 3 times 1. Don't forget the Q, plus, and I'm going to do the same thing with this one. I am going to use cross cancel again. So look for numbers top to bottom. So again, cross cancel like that. 5 and 3 can both be divided by 3. So divide this by 3, divide that by 3. Now you can do this without cross canceling, but you're going to have to do a lot of simplifying. You're going to get a big fraction, like 15 times 32 is a big number. It's going to be like a couple hundred, and you're going to have to keep simplifying until you get it all the way down. I did that with my first hour, and it just took forever. So I'm gonna avoid that, and this is another kind of a tough decision that I'm gonna have to make, because if I was doing in-person classes, I could easily gauge how people feel about fractions, how comfortable or proficient they are with fractions. But since it's over line and I can't see most of you, and I can't see you working on these things, I really don't know what you're familiar with. Sometimes I get students that are pretty good at fractions and it's no problem for them. Others, I have to go through and do this over again. But anyway, cross cancel again. 16 divided by 16 is 1. 32 is also divisible by 16, so divide it, you get 2. 5 times 2 is 10. Now 1 over 1, so the bottom number is 1 times 1, so that's just going to be 1. But I'm going to use identity property, and it states that any number divided by 1 is going to be that same number. So I don't need that number in there. But again, I would prefer to have whole numbers because fractions can be a headache sometimes. I'm not going to lie. I feel the same way. But you know, fractions are just one of those things, okay? Fractions are just one of those things, like they're just bad, but they keep coming back. Like rainy days or bad politicians, you know, you just can't get rid of them, so you just got to learn to live with them. Now, I think I also made another mistake here. But sometimes when I do this, I see if anyone catches this mistake. Anyone see what happened? Now I did this again because in my brain, this kind of looks like a fraction, but I forgot to distribute that negative. And remember, like I said, that's a big problem that I oftentimes see with all sorts of students. They constantly forget that you have to distribute negative signs as well if there's a negative sign. And again, I just barely caught that myself. So this is one of those really, really tricky problems. All right, this is one of those problems that'll bamboozle me if it gives me the chance. Okay, so I got rid of the 10. Now I have this 3/4 to get rid of. Now this is a tricky question, and if you were in my Algebra 1 class, I usually teach what I call forward thinking, and that is to think of these equations as moving forward from the variable. What number times 3 and then divided by 4 and then made negative will give me 6? So sometimes I have these things, and we'll spend a whole day just thinking about it, and kids get it just like that. You know, like 80% of the students will understand what's going on.
Mr. Nez?
Yeah.
Wouldn't it be -6?
Where? Oh yeah, you're right. Yep, you're okay. Good. yeah. Okay. Good. You're on the ball. I think it's also because I changed the color on that, so it still looks like it's kind of negative-ish. Anyway, where was I? So a number you times by 3, divide by 4. So divide by 4. We're going to get rid of this division by 4. So to get rid of that divide by 4, I am going to times both sides by 4. Times this by 4, times this by 4. Well, actually, the appropriate word is times everything by 4. So 4 times -6 is -24. And this should be negative 3q. And again, 4 times 3 is 12. 12 divided by 4 is 3. But again, it's easier to just think of it as they cancel each other out, because times by 4, then divide by 4, you get the same number again. And again, that's property of inverse. Now, I got to get rid of this 3. This one's a lot easier. This one is more familiar to people. But again, don't forget, if you have a negative, you got to cancel the negative and cancel the number. So both of those things have to cancel. Now, I'm going to do one more property, and this one we didn't cover, but you might have covered in a different class, and that is what's called reflexive property. With reflexive property, you take both sides of the equation and you just flip them. (24) divided by 3, and then they're both negative, so negative divided by negative is positive, so I get positive 8. There you go. And we have it. So if I plug A8 back in here, multiply it, divide it, add it to this, and multiply it to that, I should get negative 16. And that's a bit of work, and I really encourage checking the work, but oh man, that one's going to be a big one. And as you can see too, I almost made a mistake or two on this one myself. So this one's a pretty tough one, which is why I would prefer to go over it. Number 5 does not look that tough. There is only one thing different with number 5, and that is that it has 2 variables. There's an a on the first side and an a on the other side, the second side. So on left and right, there's an a on both sides, but that one's not so bad. You would just pick a side for a and move a over to that side. Now, this number 6 is the same thing. I have a W on this side and a W on that side. So both sides have a W. So I essentially do the same thing. So I'm going to go ahead and skip number 5 because, like I said, with my last class, I didn't really finish the whole thing. And I want to focus on the more difficult ones. Okay. Stretch out because this one's going to be another doozy. Oh, it's probably not as bad as the other one, though. 5 over 6. W plus 21 equals negative. Now I'm going to have to multiply this number by a third, so you can always turn them into fractions by putting a 1 underneath them. And multiply top number to top number, so 1 times 2, 3 times 1. Don't forget the W. Minus, and then 9 times 1 is 9. And 3 times 1 is 3. Okay, now at least we got rid of the parentheses. Now this one's another tricky one. This one I had a lot of deliberation on when I did it with my first hour, because you can work with these fractions, but there are some problems later on down the road that are going to be needing this trick that I'm about to show you. And at this point, I don't know how many people would know this trick, but my guess is very, very few people. Like I said, our school district doesn't really seem to put a big emphasis on fractions, but I'm going to show you a trick. We're going to get rid of these fractions with one big step. If you remember when we were adding fractions, we would multiply the numbers so that we'd get a different set of numbers, but it means the same thing. We're going to do the same thing, but here's what we're going to do. Look at our bottom numbers. Oh, did I miss a negative somewhere? Oh, you know what? You are right. It looks like I did. Oh, here I'm the one telling people to be careful of that. But you know, that shows nobody is safe from it. It can happen to anybody. Anyway, back to what I was saying. 6 and 3. So I have 2 bottom numbers, 6 and 3. Now there's also 1, but everything divides by 1, so I'm going to ignore that one. So I'm going to multiply everything by 6. Now 6 can be divided by 6, and 3 can also be divided by 6, or 6 can be divided by 3. Now this is a bit of a tricky thing, but it might make more sense once you see how it works. I'm going to multiply everything by 6 or 6 over 1, whichever one you think helps better. I'll just go 6 over, oops, sorry, I pushed the wrong button. I meant to push this button here. So now I'm going to multiply everything by 6. Okay, now this is, again, it's weird, but just try to follow along. 6 times 5. So my first term is 30 over 6w plus 6 times 21. So 6 times 2 is 12. 1 times 6 is 6 equals, and let's go ahead and do this part here. So 6 times 2 is 12. And bottom number is 3 plus 6 times 9 is 54, I think. Okay, don't be afraid to double check me on some of these. I missed my coffee this morning. That's probably what's going on also. All right, so you're probably wondering, why did we do that? Why did we multiply everything by 6? All right, so it's sort of like those spray-on cleaners like OxyClean. All right, you just got to spray it on, give it a few seconds, and wipe it away. So 30 divided by 6. What is 30 divided by 6? Well, that's 5. All right, nothing happened to this one here. Stays 126 because it was already a whole number to begin with. Oh, almost forgot the W on this one here. 12 divided by 3 is 4. And 54 divided by 3 is 18. And wouldn't you know, look at that. No more fractions. Sham wow. No, I'm kidding. Sometimes in my classes, I always ask if anybody has ever bought one of those things from the infomercials. I mean, like, they always try to sell it to you like it's the coolest thing ever. But like, seriously, the ShamWow is just like a towel. That's like literally all it is. And they have all these people using it like, oh my God, it's the best thing ever. It like cleaned up everything. But then it's like staged and everything. So anyway, I'm gonna go ahead and get rid of this 4W. Right, so 4W minus 4W cancels out. Now, to save space, I'm gonna do two things. I'm gonna do like a trade. So there's gonna be, one side is gonna take all my regular numbers and the other side is gonna take the variable. So here, I'm also gonna take this number as well. Now, normally, again, if I was writing this, I would probably write every single step, but writing with the mouse, and this morning my regular mouse died, so I stole this one from another computer. So it's a little bit of a different mouse. It's a little bit easier to draw straight lines with this, but it's not as precise. My curved lines kind of are not as good. Anyway, so let's go ahead and add our like terms. So 5W and 4W will make 9W. And here I get, let's see, 18 minus 126. So that's going to be negative 108. Now, I would also divide both sides by 9, but I'm a little bit out of space here. But just imagine that I divided both sides by 9, and W is equal to negative 12. Is that one? So look at my multiplication chart, which 9 times 12. Okay, yeah, that's right. It is 108. Which I have in my class, but I know it doesn't really help you that it's not here or it's not visible to you. But there we go. We have W equals 12. Okay, and like I said, I'm going to skip some of these easier ones because I want to spend more time on these difficult ones. So the next slide, I don't see any particular problem with these. Maybe we could do number 8 really quick. I'm thinking we could do number 8 really quick because we just got to do our regular stuff. Now in this case here, don't do what I almost did and forget the negative. Right? It's a lot harder with fractions because on a fraction, the fraction bar kind of looks like a negative, so it's easy to lose it, kind of not really see it all that much. So multiply both by 8, almost, gotta multiply both by 8. And I just said it too. There we go. Now we have a bit of a choice on this one because I could either add 7m to both sides or I could add 8m to both sides. So consider both options. In this case, it's probably better that I add 8m to both sides. Plus 8m plus 8m. And in this case here, well, you know what? I should also add these together. 16 minus 3. So 16 minus 3 is 13. Plus, and I'm going to add the m's together. So 8 minus 7 would be 1m. Okay, fix that up. Make that m a little bit better. There you go. And I have 8 here. So there you go. I moved my variable to one side. And it's best to put it on the left side also, because that's the side you read in order from left to right. So you want to put that variable first. But I still need to get rid of this 13. So that 13 is adding to m. So I'm going to go ahead and minus 13 from both sides. And that one didn't take that long. Pretty easy. 8 minus 13 is negative 5. And it looks like we are done with that one. Box it up. And we are done. All right, this next one here, number 10 doesn't seem, oh man, I don't know if I could do number 10. All right, well, it does have a big fraction, right? The whole top thing is a big old fraction. All that 10x plus 17 minus the difference of x and 9 is all one big fraction. But luckily, it's pretty easy for us to get rid of it. So I am going to do a few things on this top part. So 10x plus 17 minus x. And again, be careful with the distributing the negative. There you go. Now, what I want to do is I want to get rid of that 2. So I have two variables, but they're both together, so they're both on the same line. So I can ask myself, what is the 2 doing to that group of numbers? Well, that 2 is dividing. So I'm going to do the opposite of dividing, and I'm going to multiply it by 2. Now this is a little bit different because I have two terms on this side. You probably already knew this, but you would distribute that 2 to both of them because, like I said, you're not just multiplying both sides by 2, you're multiplying everything in the equation by 2. But since this is all a group, remember fraction signs are groups. So cancel, cancel, and that gets rid of that big fraction there. So you don't have to worry about that anymore. At the same time, I'm also going to work on my top number. So 10 minus x is 9x. And I'm going to add my regular numbers together, 17 and 9. So that's going to be 24. No, 26. Let me double check. Yeah, 26. Equals, and then I'm going to have to distribute this, 6x plus 2. And again, I'm going to have to do a little bit of a trade, right? So this side, I'm going to put all the x numbers, and on this side, I'm going to put all the regular numbers, all the constant values. So I want to move 6 out of here, because if I move 6 over here, x will be even. And just to save space, I normally don't do this if I have to write everything out. But space is precious here, especially if you're watching it on a small screen. So So I'm going to add minus 26 to both sides, like that. And that should cause this to cancel and this to cancel. So again, there's a bit of a trade. They're both giving each other what they want. 9 minus 6 is 3. Okay. Yeah, this one's not that hard. I don't think this lesson is really one of those ones that you should really be worried about. So, you know, even if you miss it, it's just these little tricks you got to worry about. And especially the fractions, like I said, those fraction ones, oh man. Okay. Just divide this, negative 24 divided by 3, you get negative 8. There we go. Okay. So it's just that getting rid of the 2 thing, that's the main one that I think we're going to have a problem with. So number 10, we have another problem where we have a number of fractions. Ooh, man. I don't think this one's nearly as bad as the other one, but still. I know these fraction ones oftentimes have a lot of stuff going on with them. So I'm going to turn this into a fraction, put a 1 under it. And I have to multiply both of these by 9/8. But I'm going to use cross cancel again, cross cancel. So this one and this one are both divisible by 4. So I'm going to divide them by 4. So 9 times 1 and 2 times 1 minus, okay, there you go. And I'm going to clear this off. And I don't have anything that'll cross cancel here. 8 and 1 don't have anything, and 9 and 2 don't have anything. So sometimes it'd be like that, 9, 16, and this is that problem I was probably saying 16ths on all the time, because that is 9/16. All right, 3/4. It doesn't look like there's anything I can do about that. And 3 times my top number, or again, you can put a 1 on the bottom here, just put a 1 under 3. 3 times 5 is 15, and 3 has a 1 under it, so 1 times 2 is 2. Oh, I almost forgot the A again. Gosh, I'm just a little bit spacey today, I guess. All right, now we're going to do that same trick. The same trick we did before to get rid of the fractions. So if you think you got it, or you don't feel like you got it all the way, I'm gonna show you again. So look at your bottom numbers. I have 3 different bottom numbers: 2, 16, 4. Now 16 can also be divided by 2 and 4. So the biggest number that I can divide all of these by is 16. So I'm going to have to multiply all of these numbers by 16, or 16 over 1. And again, this is going to be a bit of work. So 16 times 9. So that's 160 minus 16. So 150, 154. You could double check me on that one. Wait, 160, it'd be 144. 160 minus 16, 160, yeah, it'd be 144. 144 over 2 minus, and then 16 times 9, same thing, 144 divided by 16. Bottom number hasn't changed, because remember, this is over 1. A equals, 16 times 3 is 48, so 48 over 4, A plus, and then 16 times 15. I know 15 times 15 is 225, but 16, so I guess I'd have to add another 15, so 225 plus 15, so 240. Yeah, it'd be 240. 240 over 2. Some of these just give us big numbers. But you know, the good thing is after this, we won't have to deal with any more fractions. Well, in this problem anyway. So 144 divided by 2. I think it's 72. So 72 minus, and then 144 divided by 16. Now that one I don't know right off the top of my head. 144 divided by 16 is 9. So 9a equals 48 divided by 4, so that'd be 12, because 40 times 10 is 40. And 240 divided by 2, so this would be 120. Now, even though we have big numbers, we don't have fractions, and that's good, right? Because fractions are the tough part. Big numbers, big numbers, they shouldn't scare us anymore. Now, I'm going to keep a positive, and you actually have a choice here. I can minus 12a and have a be negative, and then just divide both sides by a negative number. Or I can keep a positive and add 9a to both sides. So a is on this side, and you'd have something like 21a or something like that. But I don't know if it really matters, but let's just go with one of them. I don't know which one to go with. I'm gonna just go with minus 12a. I just sort of flipped the coin in my head. And since I minused this side here, I'm gonna minus this number here. So minus 72. And I get, let's see, negative 21a equals, and then 120 divided by, let's see, it looks like this one's a lot different than the other one. Let's see, 72 would be 23. No, wait, no. How much would that be? 120 minus 72. I don't want to make any mistakes, so I'm going to play it safe. 120 minus 72. Okay, 48. So I get 48 here. And this doesn't look like it's going to divide nicely, so let's go ahead and just a equals negative 48 divided by 21. All right, like I said, that one was a bit of a tough one. I wouldn't be too worried about that one. At least you got it here, so don't worry about it. All right, so the next one I have are special cases. I wish there was a little bit more on these. I wish these popped up more regularly on just like everyday homework assignments, because these are pretty rare, but they do happen. And I kind of don't like that they only appear like when they say they're going to appear. So people get ready for them, but I think people need to be sort of ready for them all the time. So I kind of wish I could get more of these in homeworks. A lot of times I just use what I have. Sometimes I make them myself, but let's see what happens. So these are, again, special cases. They don't happen all the time, and in fact, they're pretty rare. So 1 plus 3c equals 5 minus 5c, so multiply both of those by 5, make that c a little bit better, plus 8c. Now I'm going to combine these two together. 1 plus 3c equals 5. And let's see, 8 minus 5 is 3. So plus 3c. Now you might notice something is a bit weird here, because I usually tell people to look at your variable first And here I get weird things. So if I want to get rid of this 3c, I'm going to minus 3c from both sides. And that cancels here because 3c minus 3c. If you have $3 and you spend $3, you got $0. 5. All right, nothing happened to the 5, so I'm going to leave it there. And 3c minus 3c, right? That is 1c. Now, that's what I see all the time on work that has this kind of problem. I'll be following the work, and I'm like, wait a minute. How come you have 3 minus 3 is 0 here, but 3 minus 3 over here, the exact same thing, is 1? And it's probably because people know that something is wrong when they don't have a variable. Where did it go? It's gone. So what happens when in this case here? So if I try my best to solve this, I get 1 equals 5, which is a false statement. 1 is not the same as 5. And I have no more variable. So what can I do? So again, this is a special case. There is no solution. And this isn't the first time you would have seen something like this. If you were following in the previous lessons, we had radical equations. And in radical equations, you have to look for extraneous roots or extraneous solutions. And sometimes those solutions don't work out. Even though you did the math right, they just don't work out. So again, it's a pretty common thing that happens, especially in Algebra 2, where you just run into a problem that cannot be solved. And sometimes it be like that. Okay, now there is also another type of case that happens, and let's go over that. 40 minus 8 x equals negative 8x, because we're going to multiply that out. Negative times negative is positive. Make that plus sign a little bit better. Like I said, I got a new mouse today. It's not really a new mouse, it's an old mouse. But my handwriting is a little bit different. It's not as precise as my other one. But the good news is I can make vertical line or horizontal lines really easily. Usually my horizontal lines are always kind of off. And speaking of things that are off, this number 12 looks kind of off. Okay. Besides that, what else is kind of weird about it? Well, both sides kind of look the same. They both have a negative 8x and a 40. Okay, well, let's try solving this more. I get negative 40. Let's see if we can get this down. Now again, if you have any number subtract by itself, it's just going to be 0. So it cancels out. Negative 8x equals, and the only number I have on this side is also negative 8x. So what's happening with this one? It's not quite the same because I can add 8x to both sides, and I would get 0 equals 0. So what does that mean? Does that mean there's no solution? Not quite, because this one is a different case. And in this case here, we could try our best to simplify it even more. Let's see if we can just get the x's by themselves. In this case, I divide by negative 8, so divide the negative, divide the 8, so they cancel out, and I get x equals x. Or again, if I were to divide everything, I could get 0 equals 0. Now, in this case, it's true. Both of these statements are true statements. 0 equals 0. X equals x. And if I plug in, like, say, 15 for x, 15 equals 15. That's true. What if I plug in 100? 100 equals 100. That's true. Negative 5 equals negative 5. That's true. So everything is true. So anything that's a real number, anything I throw in there is going to work. anything in there is going to work. So we say all real numbers. So again, they're a little bit different. They both kind of have similar things in that one is what they both can lose their variable. But if you can make it a true statement, then it's all real numbers. If it is a false statement, like 1 equals 5, 1 is not the same thing as 5, then it is no solution. All right, so I think I'm going to do this one here, number 4. And like I said, I'm trying to keep these lessons on a time frame. So let's keep it here and there. So what I'm going to do is I'm going to cross multiply. Now be careful, because earlier in this lesson we were working with fractions and we did something else called cross cancel. Cross cancel and cross multiply, I get people that confuse those two terms all the time. But in cross multiply, you are multiplying across the equal sign. So this top number times that bottom number, and this bottom number times that top number. So I drew colored lines so you can easily see which one we are looking at. So I'm going to go ahead and do this one here. So 10 times, now because it's grouped, remember fraction bars are grouping symbols. So that means there is a parenthesis around the 2x minus 8. There is also a grouping symbol around the 5x minus 9. So that means I'm going to have to times 8 times 5x and 8 times negative 9. And then from here, I'm just going to work on it like it's an ordinary algebra problem. And that's pretty much how you do proportions. So proportions are, from here, it's just the same as any algebra problem. So 10 times 2 is 20x minus 80 minus 40x minus 72. And for this one here, I'm going to add 20x to both sides, so plus 20x. So on the last one, I made the x go to the other side so that it would be negative. And you can do that too. Again, in this case, there's no clear-cut best way to do this, so sometimes you just got to stick with whatever works. So since I cancel it from this side, I'm going to cancel it from this side, the regular number. So add 72 to both sides. So 72 minus 10 is 62. And this would be 60x. Now, is this, am I doing this the right way? Somehow I feel like I made a mistake. 20x minus 8 and 40x minus 72. No, that's right. Or did I, let's see. 72 minus, oh, okay, I see what I did wrong then. I added this when I should have subtracted it. So that would actually be 20x down here. There you go. I worked on these a little bit ahead of time so I wouldn't have anything like that happen. But there you go. X is equal to 20 divided by 60 is 3, and 2 out of 20. So that would be dividing both sides by 20. So that'd be 3 and, wait a minute, 62. Or did I make a mistake on this one too? Negative. Oh, okay. Darn it. And I'm just trying to go for speed here, but that should have been 8 here because 10 times 8 would be 80. which would only change this here so that I don't have negative anymore. And that would be actually negative 8. Okay, there you go, negative 8 over 20. Simplify that, so negative, okay, so 8 can be divided by 4, and 4 divided into 20 is 5, so that's going to be x is equal to negative 2/5. Ooh, that one could have ended badly. All right, but I'm glad I did that one, though. Okay, let's go ahead and move on from here. So like I said, if you have your packet, you already have the problem, so you just basically got to follow what I'm doing. Now, these are the main ones I really wanted to focus on today. So these are the ones I was trying to get to really quick. Now, when you're solving a problem like this, a lot of times you cannot combine like terms. So you're not really going to lose anything. You're going to end up keeping everything, but you're just sort of moving things around. So here I want this pi by itself. So I want to get that pi by itself. How do I get rid of the 2 and the r? Well, what are the 2 and the r doing? They are multiplying. Since they are multiplying, I do the opposite and divide both sides by 2r. So 2 cancels, r cancels. I am only left with pi, and I'm going to use reflexive property again. And I'm going to switch to pi, so it's over on this side, and c over 2r. And there you go. We solved for pi. This is a little bit of a tricky one. These ones with the fractions always are. I have a half here. So what does a half do? So if I want the p by itself, how do I get that half out of there? And this one again is a bit of a tricky one. But what does a half do? So if I half times the number, so let's say half times 20, or half of 20 is 10. So actually it's dividing by 2. So I'm going to do the opposite of divide by 2 and times it by 2. So I get 2a equals, and then I'm going to, okay, so half of 2 is 1. 1 times ap is just ap. So I got rid of the fraction now. And I know that one's a bit of a tricky one. So I still need to get p by itself. So I'm going to get rid of this a. So divide both sides by a. So p is by itself now. So I'm going to switch the sides. So p equals 2a over a. And if you're wondering, why don't you just cancel the a? Now, one is capital and the other is lowercase. So we don't know what exactly they are. This, to me, looks like the formula of a triangle, which is half of base times height is the area. So in that case, they wouldn't cancel out. So play it safe, and if they're not the exact same thing, then don't combine them. All right. And again, if I have ones with fractions in there, those are always the ones that are pretty tricky. So I want to get b by itself. So this means the c has to go. And again, we're going to do the exact same thing. And don't forget that every time you work on these kinds of equations, it's the exact same steps. If you can solve regular equations, apply those exact same steps to these. So again, this is divided by c, times it by c. They cancel out. So that leaves me with only a over b equals 5c. Now I got to get this a out of here. So minus a minus a. Now again, these are not like terms. So I cannot combine them. I cannot get like 5c or 5ac or something like that. So since I can't combine them, I'm just going to write them all out, 5c minus a, like that. And it is solved now. We have b by itself. Now, if we ever come across the values for A, B, or C later, we can plug them in and we should still get the same solution. We should still get the same answer no matter what. All right, so let's go ahead and get this one x by itself. So first I'm gonna do is add 3y. So let's get this 3y out of there. So that leaves me with 3x equals 24. And again, they're not like terms, so I can't put them together. But I still got to get this x by itself, and that 3 has to go. So divide both sides by 3. 3 is now gone, and my x is free. 3y plus 24 equals that. All I did was switch the 3 and the y together because yesterday I was saying anytime you have something like that, make sure you have the variable go first before the regular numbers, before the constant values. So there you go. We do it. And again, you're just following the exact same things that you would do with normal equations. All right, here we go. 7w, and I'm going to distribute. I'm going a little bit faster because hopefully you should kind of see what the process is. So I distributed the half, so it's half w plus half v. And I'm going to do that same trick. Look at my bottom numbers, it's 2. So this one should be a much easier one. I'm going to double everything. So if I double 7, I get 14. If I double half, I get 1, right? Because it's like if you have 2 halves of something, then you get the equivalent of one of those things. Like back in the old days, they used to have half dollars. So 1w and 1v. Now I just got to get that v by itself and minus w from both sides. Switch sides, v equals 13w, because in this case they are like terms. Since they are like terms, I can go ahead and combine them. This is like the only example that we've been able to do this with. Okay, last one. We've just about made it. It's been a long journey, but we finally got to the end. S equals, and I'm going to multiply both of these by 180. Now, usually when we're used to distributive property, we're used to having the number in the front, but it can go backward. It can go backwards also. So 180n minus, in this case here, we got to double 180, so it's going to be 360. But we want to get this n by itself. So this 360, it's got to go. So we do the opposite or the inverse and add 360 to both sides. Now this is s. I almost mistaked it for 5 earlier. All right, there we go. Now, remember when you do something like this, like in this case, I want to get rid of this 180. I usually say divide both sides by 180, but as I've mentioned on another problem, that's not exactly what you're doing. You're dividing everything by 180. So you could do it that way also, divide both sides by 180 or divide everything by 180. But in this case, I'm going to divide everything by 180. Because I can divide 360 by 180. So I get s over 180 plus, and 360 divided by 180 is going to be 2. Now 180 cancels out, and that leaves me with just the n, and I'm going to put my n value first, my n variable. So there you go. That one we weren't able to solve all that much. But, at least we got the n by itself. And that's pretty much it for today. I tried to keep these lessons nice and compact. Maybe we could go back and work on some of those problems that we skipped if you want to. But for now, for the actual lesson, I think we are done. And see you tomorrow.